Thank you very much. Deploying Go function. Deploy Go. There. Any questions? Thank you. I'm glad that you applaud, because making something that simple is actually really hard. And the reason I like to show this is because I didn't have to write any code for that. This was something I could just deploy. This is written in Go, and I can actually try it to see. I have this picture there. I copy the link. And let's see if it takes a bit of time. Is the warm-up. And there, I have a face detection that is ready to use in a few seconds. So what do you think the time I would have spent building my own? It's the amount of work is actually quite hard, and we often, as developer, underestimate the work that is being done. So what I want to show with this talk is really sometimes that you might have a lot of things that you can do, but the question we want to ask here is, should we do that? What should we focus on? What is the important thing? For that, I use this project called OpenFaas. And with those 3 lines there, you can repeat what I just did. It's nothing fancy, but I also use another project, and that is called Linked. And if you look, I deployed another function as well, which is called echo. It does nothing but repeating the echo. But the reason I use this is because I can have a little test here. And there I see all the routes with the latency that gets called. So again, I didn't have to write any code for that. I get that for free. So with almost no code, I have a lot of, I would say, vision, observability into my system. And that is something that is tremendously powerful. Of course, what's interesting as well is, since you put those servers on the internet, you need to see a bit of how they behave or how they reply. And for that, I didn't have to build that dashboard. Like, building a dashboard is something that is actually quite hard. And even harder is to get the many different teams to use the same kind of display for a dashboard. But how does it work? So if I had to build it myself from scratch, how should I do? And the reason I show that is because the design, the architecture of OpenFaas is really brilliant. I love it. So this is a simple Go program. All it does is it takes some input from standard in, throw some error if there is some, and then call this function handle with the input that we read from standard in and print it out in standard out. That function, that part is called a template. That function, has just one function which reads a sequence of bytes and returns a sequence of bytes. The interesting part is really that when I read the code, I was like, wow, 227 lines of code. This is something that in 10 minutes I can read that. And so in 10 minutes, I can read how to do face detection. And if you look, most of the code here is mainly just how do I process that byte stream that I receive. So you see, like the handle function, I have some parameter. So if I get a URL, I go fetch that URL the same way I saw that. Here, I remove the temporary file. I parse the query if I have some. Here, new face detector. And here are some parameters. So if I had to modify that code, it wouldn't take me so long to understand and go and adapt it to my needs. This is what, like, in a matter of minutes, you can get going, as opposed to, okay, I have to build a new service. I have to think ahead. And by the way, Just pure question, how many times did you create a new service and it took more time to deploy it than to build it? Okay, half the room, about half the room. I'm glad I'm not alone. But so, you have that template that's calling that function, but now how do you deploy it? Well, container seems like a good interface. Container are a pleasant way that you can specify a build script, and with that build script will generate a container image, which is basically a zip. And that zip can be deployed and run almost anywhere. And you see here, they pass an environmental variable with the handler, expose some port, and this watchdog will just listen to that F process and convert whatever HTTP requests coming in and pass it to the standard in of that handler program, and get the standard out and package it into an HTTP request and send it back to the client. And that's it. I mean, that's really what I like about this simplicity is in 5 minutes, I could explain to you how to build your own and how to improve on it, how to make it your kind of like your own project. And so the way it works is as simple as that. You have an API that takes a route and routes it into those containers. That container has a watchdog process that gathers the HTTP request, feed in it the standard input, and then the standard output is sent back to the client. This is how you make a serverless framework. It's nothing magical. So why deploying Go function? Because simplicity is complicated. And I saw that talk from Rod Pike a few years ago at .go, and that really inspired me to like give a bit of the credit for all the people who do the hard work that you don't see, basically. We don't see. I just use it. I forgot it's there. And a fun fact about that is I never really paid attention to that kind of things until I read that book, The Art of Unix Programming. This is really because Rob Pike's name was all over the place, and I was wondering, like, what happened? And it's not that Rob Pike didn't invent Unix, but he worked on it apparently, and he was very influenced by it. And I really like this Unix mentality that you have small, manageable units that are swappable, where you just pass stream and you can easily compose them. I think it's very much aligned with the philosophy of Go. Another thing that we underestimate is how do we get production-grade infrastructure? Because even though the name serverless is kind of a overused term, when you want to have production-grade infrastructure, you have to think about a lot of details. And those details takes time. Even if you use a managed service, you might have to think about what if that service goes down? How can I migrate the data? What should I do? How to integrate many clients to that one server and all those things. And if you want, you can watch that talk by Evgeny Birkman. It's really, really interesting to see how much work goes into actually managing infrastructure. The thing that going to the cloud isn't just going to happen tomorrow. If you want a full cloud infrastructure, this might take you up to 6 months. It's like, I've never seen it. 2 years seems more likely. I would say 5 years if you have a company that is not in the cloud. And so the reason, why does it take so long? Just imagine the lamp is broken, so now you have to go to the shelf to find, but the shelf is broken, so you need to fix the shelf. And the problem is that the screwdriver is in the drawer, but the drawer lacks oils. So you go and pick up the oil, but the oil is empty, so you have to go to the store to buy some more. And then finally you're in the car, and the car has a problem. So there your manager comes and says, why is the light not working? And you say, I'm working on it. And so that's really how it works. The little light on the website, and suddenly you are managing a mess of certificates going outdated somewhere. And I have a confession to make. I'm guilty of saying this. I've said that, and I regret it deeply, deeply. We should build X. Who said that phrase? Well, nobody. Did you enjoy the experience? I completely regret it because I totally underestimate that actually whatever you write, you have to maintain. That maintenance cost is really overlooked. And so, yeah, the mentality that why deploying Go function is that we could build something. But it's better if we focus on the actual problem we're trying to solve. You know, I see many companies, they are doing some processing of some kind. They might not have the time to deal with some low-level libraries or something. They should not write their own. They might be better reusing something and actually have people who understand the domain that they're using. Not everybody is Google, I would say. And that comes when you have to talk to people, okay, what is the strategy here? What should we use? Should we build something ourselves or should we buy something? And this is from the one person who actually built the Google data center. And I'm going to read what he says. He says, so Lyft is paying $8 million a month into AWS, almost $100 million a year. Each ride costs 14 cents in AWS rent. I keep hearing they could build their own data center and save. My early days at Google Cloud heard the same from customers. At scale, owning is cheaper. It wasn't. They all came around. Here is why. You can read the whole thread, but the main idea is that when you have to build or buy, you have to remember that a restaurant, for instance, they buy, cook, and sell food. Very few restaurants do farming, and even fewer are good at it. So it depends really how much time you have on your hand to actually get good at something. And it's something you can control. Like, not everybody is supposed to be good at designing UI, or not everybody is good at doing distributed system, but you can choose to be good at. It just takes a lot of time to get good at that. And another overlooked point is really that we have mental limitation. So our brain doesn't scale infinitely, in case you didn't know, but you have a limited amount of decision you can make per day. So if you're above that threshold, you're useless. Like, you cannot even choose what you want to eat. And you also have a limit to the number of things you can remember. Have you ever read code and have to say, like, what is this value? And it's there, but so you have to remember that this is there, and this is there, and finally someone interrupts you, and you come back, and you completely lost whatever you were reading. So those processes are really common. Also, the speed of memory. Like, yeah, you built that library 6 months ago. Do you remember everything about it? Yeah, it gets a little time to flex those muscles, I would say. So those three things are really something that we underestimate. And it's good to keep them in mind whenever you say, I'm going to build my own library doing networking. Or have you ever implemented a retry logic somewhere? It's, well, yeah, those things have a lot of details that are hard to get right, and it only is what we call battle tested that they get good. And for that, there is one good way, is consistency. So there is this beautiful paper that I find doing research about chaos engineering and resiliency. So basically, it says that it's an analysis of pilot errors during operating aircraft. So just imagine that they categorize the error of the pilot in different categories. One of them is called substitution error. So you're a pilot, you go into a plane, and you make mistake because the altitude and the speed or some control are not in the same place depending on the plane you're on. That becomes a problem. So 50% of all those errors are created because the dashboard is not consistent. They put the same dashboard on all the plane. They didn't standardize the plane. They just standardized the dashboard. And that removed, like, half of the mistake were gone already. So think about it, about the tooling that we have, how nice it is that to have the same consistency. I would say that most problem we have is that we make too much custom code and not enough code that are generated. Like, why not use the code generation, which would generate the same code over and over? And so why deploying Go function? Do you know that repository? Let's go have a look. So it's called no code. It's the best way to write secure and reliable application. Write nothing, deploy nowhere. When somebody asks me how many times per day do you deploy, I say 100. 100 times a day I deploy no code. So this is something that can really improve your productivity, because no code is the best way. And say getting started. Start by not writing any code. So far, I'm sure everybody can do that. This is just an example of an application. You see? Beautiful. The possibilities are endless. And what I like is that there is 368 pull requests for, like, if you're bored one day, just go through those pull requests, because fix all the bugs, like, you know, delete all the code, intent to micro front end, fix nothing, update Docker file. That's what is really good. And the worst part is they have issues as well. So you have a non-issue here. I don't know how they do it, but it seems quite nothing. OK, perfect. So you get the idea that actually you're better off not writing any code and actually agreeing upon something. I think if you want to know, can anybody tell me another scheduler than Kubernetes? You don't know? Mesos, yes? Sorry? Yeah, exactly. Those, there is a Nomad from HashiCorp, but we barely talk about them. And I think that Kubernetes is one because everybody agrees on it. You know, people build stuff on it. They just, OK, this is the platform that you are in now. And so the mindset is more like you want to connect service. Is not the same as building a high-performance network library as it is to write glue code that will connect two services together. Like, how hard would it be to connect this face detection, you know, little function with another service? That wouldn't require that much code. It's still code that we need to maintain, but it's much better than to bundle everything into one and have it to maintain for the rest of your life. And if you want, like this talk is actually quite insightful, if you like, because Patrick Debois is the person who coined the terms DevOps. And he talked about from serverless to serviceful, because serverless is, I think the words are in the wrong order. It's not I want serverless, is I want less server, meaning I want to focus less on server. So that's my take on serverless, and serviceful doesn't have that sweet taste as good. So yeah, we'll come back to that. But for instance, nobody say I have to build my own mail server. Like, that's something I never heard, because apparently mails are really hard. SMTP is not easy. But also maybe your own chat. Some people have built it. But you don't say, I have to rebuild my, I have to build a file hosting, or, you know, your code. Yeah, it's Git, but, you know, you're not going to reinvent Git. What about payment processing? Do you feel secure knowing that your code is processing money right now? So it's all about trade-off. And those trade-offs come in many forms, and the best thing is to be aware of them. Like, if you go willingly making a trade-off, you know what you're giving up, and you know what you're getting. For instance, you can trade off developer time versus paying for a product or using an open source library. But it's still time that you need to invest. Or if you move from on-premise, which has a fixed capacity, and people who code the application for those on-premise have a different mindset than people who build services in the cloud, because in the cloud you pay for what you use, so you're very careful about about waste. And also, yes, serverless is not very latency efficient. So if you need something that replies blazing fast, maybe that's not the best thing for you. But if you need throughput, that is really good. You can really easily scale much further than if you had one single service. And that's all depend on your strategy. It's all about that. It's all about how do you approach, how do you solve a problem, and how do you compare the solution. And for that, there's another person who made a really great book about it. His name is Simon Wardley, and he talks about mapping. You need a map for your strategy. And basically, the idea is that you start from the customer need, and you go all the way down to, for instance, power. Nobody say, I have to reinvent electricity, because you laugh, but you would be surprised. It's a commodity. It's something that's just there. You buy it. Like, I'm not going to reinvent internet. I just go to a subscriber and you buy it. And that's the same thing. People try to build data center. They don't realize that they have to go to a telecom company that's probably going to charge premium just to connect it. And on top of that, you have to think about, okay, now you have to train personnel. You have to think about outages, about disaster. Because, yeah, now suddenly the planet is going crazy and you have a high wind and fire and water going all over the place. So you have to think about those things. And if your business is not to build data center, that is time that is taking from your business. So why deploying Go function? Well, there is this trend now that we want to shift left. So shift left testing is more like bringing more of the trade-off early on in the code so that you know what you're up against. So instead of going all the way from code, build, test, deploy, and monitoring something, you can easily go and say, okay, maybe we should have that as code. How about our policy? How can we access things? I'm pretty sure now we all have the Docker build is a build as code. It's a way to package your application. And so everything now is almost as code. You can have infrastructure as code, you can have config as code, build as code, policy as code, deployment, pipeline, and even resiliency. So for each, I put some example of tools that you can have, because I think it's really important to know them and to make sure that you understand the trade-off you're making by using those tools. Because, for instance, if you want to codify your resiliency, you can use Chaos Toolkit, which is a tool to create chaos experiment. So meaning you can have a script defined in a language of choice, usually it's YAML or JSON, and have, okay, this is what should happen. This is the outage that I want to create. This is the result that I expect. But at least you know exactly the trade-off you're making, because this doesn't prevent your application from crashing. You just know how far you can go before it crashes. And that's a completely different dialogue. You say, yes, it scaled until that point. And then you can have a very constructive conversation with whoever is impacting you for future request. Also, you have an open policy agent. If you're working in some kind of where the data are really sensitive, or if the law requires you to work and give access to certain people about certain things, you might want to codify that, because the auditor are going to come and they have to look through everything. And if they don't understand what you're showing them, they're not going to give you a license, or they can create problem for your business. So this is really about being more aware of the business side of things. Yes, we are developer, but I switched from developer to being a site reliability engineer. And I think that when we focus about the business side of things, it's more of you can bring so much more value to your organization. And so we can maybe try to deploy, because right now this is like the little OpenFaas is running on my machine, you see? This is localhost, but what if I want to deploy in the cloud? Well, I can use this new thing called Cloud Run, and I think it works quite well. Let's see. So this is actually taking the container that I showed you that do the face detection. It's going to take that image and deploy it somewhere. I don't know where. Well, I'm sure it's in America, but the meaning is that I don't really care how it runs. I just say, this is my container, please run it. I don't have time to write Kubernetes YAML and everything. I just want this to run. It has an endpoint, it has a port. Here you go. And so the good thing is that it does that for me. I just take that URL. Might want to export. And so I also have an image here. That image is the same image of the astronaut. So let's see. And now I'm going to curl sending that image to the function that I just created. Yeah. It's a bit slow, though. There. And so this, I don't know where it's running. I just know that this is my endpoint, this is my data, please do something for me. And of course, it has trade-off, meaning that you can only have 80 connections per container or that kind of things. The pricing model is a bit different. But I did it in less than a minute. I can bet you anything that nobody can write code as fast as that. And so I put some resource here if you want to try it yourself. I think it's important to have new ideas, to try new tools and see new things. I also put a URL if you want to learn more about Kubernetes and see about the trade-off that you have to make when going on a big platform like that. I think it's a good thing because it allows everybody to work on another level. And I think I didn't talk a lot about Go here, but Go is implied because it's really a language that is simple enough and allows you to do complex things. And so this is my last slide, and I'm really sorry if you had to maintain my code. I know people, maybe somebody watching is maintaining my code somewhere. I am so sorry. So that was my talk. Thank you.
Thank you. Thank you very much. Okay. Okay.
Thank you very much for your talk. It was incredibly interesting, and I really feel the experience in development in general, because I also think the same approach, writing no code, but what could be better? However, on my previous project, I use hybrid approach actually. So we were deploying to Amazon Lambda, same serverless, but we actually created a wrapper over a Golang HTTP package. So we just didn't care where we deploy. So we just wrote an application. It was on a Lambda initially, but then we decided to move to Kubernetes. We just move it, and Go actually really allows to do that.
Yes.
So thank you very much. Unfortunately, it wasn't a question.
No, but it's good because it allows me to speak a bit about the trade-off that you're making going serverless instead of going with container and Kubernetes. Let me ask you a question. How much work would it take for you to go from a container to serverless?
One environment variable.
Yeah, I don't know, like the amount of work, as opposed to going from a very small function to a container. Like what would take the less time?
I would say going from function is easier always.
It's easier because you're just adding things. Removing things is dangerous because you don't know, is this used somewhere? But actually adding things is something that you can do very easily. Like you can always add more. Just look at NPM, they're just adding more JavaScript to everything. So that creates that suddenly I'm pretty sure I have gigabytes of Node.js script on my machine just for that. Adding is easy, but removing is actually the hard part. And that's why I think Go is brilliant because it doesn't have too much. You cannot go wrong. You have one way to do for loops. You can actually focus on the problem, the problem that you're solving, not discussing about comma and everything. Like all that things are done for you. You can get up and running much faster. And I think for a business perspective, if you go with Go and serverless, you'll be much better off, and you reach to market much faster than if you start with any other language. I might be wrong. I didn't try all the language, but for me, it was that experience that I can be there really fast.
Thank you very much.
Thank you.
Is anybody here? Does anybody here have questions?
Hey, thank you for the talk. You said you're site reliability engineer, right? So when we are using functions as a service, we are adding a layer of abstraction. And that gives us the faster velocity, but we also get that if something goes wrong, we have a hard time to find out what actually happened. Where do you draw the line between knowing how stuff works to the bones and going fast?
So the answer is not a direct answer, but I will try to answer it. It's here. If you have your strategy, you can bet on technology and say, okay, this is the technology I bet on for the next few years. So that makes sense that I learn it. On the other hand, someone will write a library and that someone will leave. That person probably didn't write a lot of documentation. So you're in exactly the same position as in the cloud provider. So it depends, where do you want your, who do you want to blame? No, that's not the right word, but it's more, you understand what I mean. Like the biggest thing is your past self. The biggest mistake I did was to think that in 6 months I will be free from that. And here I have somebody that gets paid when I use a service to fix their problem. And doesn't mean that I'm not responsible to my user, because I still have to think. But then I'm thinking at a higher level of abstraction, like how can I make this thing resilient, instead of I have to plan for things never to fail, which is almost too much hard work. So here you are thinking at a different level of abstraction, not so much into the details. You see the bigger picture, and that's really what this strategy is about.
So you should use bigger products because if they fail, everyone fails, right?
I think you should know the products you use. That's all I'm using, whether you build them or not.
Okay, thank you very much.
Thank you.